Hey everybody, welcome to the second video for Cumulative Review Packet number 10. Let's start here with number 11. I noticed that I do have 4 terms. I do not have a GCF that I can take out of everything, so I'm going to start grouping. And if I look at the first 2 terms, I can take out a 9 and an x squared, and I'm left with x plus 2, 18 divided by 9. Bring down the subtraction sign. Biggest number I can take out of 25 and 50 is 25 itself. And if I do negative 25 divided by negative 25, I'm left with just 1x or x. Negative 50 divided by negative 25 is positive 2, not 25, so positive 2 there. So then my parentheses match, and I have x plus 2, and then 9x squared minus 25. Now, it's really tempting to be done here. However, I do want to point out to you that we do have a quadratic left over. So whenever I have something that is squared, like many of the examples we've done so far, like here we had an x squared left over, and every other problem we've factored has generally been x squared. So whenever that happens, let's see if I can continue factoring. Just like this example above where I had something squared minus, I'm able to keep factoring. So I still have my x plus 2 here, but if I want my middle term to technically be 0x, and I have perfect squares here and here, I would have 3x times 3x gives me 9x squared. 5 times 5 gives me 25. Middle term of 0, 1 positive and 1 negative. So now I've gotten this down to all my x's being x to the first, which is a good thing. Remember the previous example, I couldn't factor this because of that plus sign. Now if we transition to not only factoring, but factoring and solving, we actually want answers for x, but it's done the same way. We need it equal to 0 in order to use the zero product property. So this first example is equal to 0, and the first thing I still think about is, do I have a GCF? Yes, I do. I can take out a 4 and an x, and when I do so, I'm left with 1x minus 4 equals 0. What I'm left with is a binomial that's not squared, so I can't factor anymore. So what I can do is do the zero product property. 4x equals 0 as one equation, and then 1x minus 4 equals 0 as the other. So this example, I would get x equals 0, because when I divide by 4, one of my answers is x equals 0. And my other answer, if I add 4 to both sides, I'd have 1x equals 4, or just x equals 4 as my other answer. Makes sense. X squared leads to 2 answers. Number 13, we are not equal to 0 right now, but I do have something squared. So I'd have to add the 27 over to the other side. So I'd have x squared minus 6x plus 27 equals 0. None of these are like terms, but now that I have it equal to 0, I look to see if I have a GCF. I don't. I can't group it, not 4 terms. But I do have a trinomial, highest power 2, lead coefficient of 1, which means I can go straight to my double parentheses. X times x is x squared. 2 numbers that multiply to be 27 and add to be negative 6. Well, my only options for 27 is 1 times 27 and 3 times 9. 3 and 9 can become negative 6 when added if you're doing negative 9 plus 3. Which means over here, we'd have a plus 3 and a minus 9. However, we're not done because we have to try to solve the equation. And so we'd have one equation of x plus 3 equals 0, and the other one as x minus 9 equals 0. If you solve this one and subtract the 3, you get one answer of x equals negative 3. And if you add 9 here, we'd get the other answer of x equals 9. Example 14. It is equal to 0. That's quite delightful. I look then next to see if I have a GCF. I do. I can take a 3 out of all terms, and I could take a single x out of all 3 terms. So if I do so, this is actually going to go from something that's x to the third or cubic to hopefully something squared so we can factor. 3 divided by 3 is 1. X cubed, take out 1 is x squared, plus 3 divided by 3 is 1. Take 1x out of 2, I'm left with 1. Negative 60 divided by 3 is negative 20. X divided by x is gone. So here's what I'm left with so far. When I look to see what's left, I, like the previous example, have a trinomial, highest power 2, number in front is 1. So I can keep factoring this piece and ask myself what multiplies to be a negative 20 and adds to be technically a positive 1. So my options for negative 20 are 1 times 20, 2 times 10, and 4 times 5. 4 and 5 can add to be 1 if you have 5 minus 4, and negative 4 times 5 is negative 20. So I'd have x times x is x squared, minus 4 plus 5 gets me this relationship, equals 0. So now, anytime I see an x, I set all three pieces equal to 0. So I have 3x equals 0, x minus 4 equals 0, and x plus 5 equals 0. And if I solve them all separately, it makes sense that I'd have three answers because it was originally x cubed. My first answer would be x equals 0. My second answer, if I add 4, would be x equals positive 4. And the third answer, if I subtract 5, would be x equals negative 5. Three answers for something that's cubic. The next example, number 15, it's equal to 0, so yay. I look at what I have, can't group it, not four terms. Doesn't look like I have a greatest common factor. It does look like I have a binomial, but I could rewrite this as a trinomial, 25x squared plus 0x minus 4 equals 0. I do notice that my first and last term are perfect squares, so why don't we avoid split the middle completely and say what times what gives me 25x squared? 5x times 5x. What times what gives me 4? 2 times 2. How do I get a middle term of 0? Well, I need one of them to be positive and one of them to be negative, because I have positive 10 and negative 10 now to get a 0. Because it's an equation, I have to set both of these pieces equal to 0. 5x plus 2 equals 0, and 5x minus 2 equals 0. If I solve them separately, this one I subtract 2, I would get 5x equals negative 2. Divide both sides by 5. So one answer would be negative 2/5. In this example, if I add 2, I'd have 5x equals 2, divide by 5. So I have another answer of positive 2/5. Number 16 looks like it is not equal to 0, so I'm going to have to move the 18x to the other side. Now, be careful on this one that you put things in the correct order. Everything should be in standard form. So the negative 18x would come next, and then the positive 81 equals 0. I look at what I have left here. I do have a trinomial, highest power of 2. Lead number is 1. I do actually have perfect squares, so you could use perfect squares, or you could even think about what multiplies to be 81 and adds to be negative 18. Well, 9 times 9 is 81, and if I want to get negative 18, I could do negative 9 and negative 9. So now I can go straight to my two parentheses. X times x is x squared. 9 times 9 is 81, and both of them would have to be negative to combine to be negative 18. Now notice, if I set these both equal to 0, it's the same parenthesis twice set equal to 0. So both times if I add 9, I will get the answer x equals 9. So this time, there's only one answer for x, just positive 9. You only need to write it once. Number 17, it's equal to 0. That's good. Zero product property can work. I look at my trinomial. I can't group it because there's not four terms. I look to see if there's a GCF at the beginning, and there is not. I look to see if I have perfect squares on the ends. I don't, which means I have to use split the middle here. So the first step for that is to multiply the first and last terms, a times c. 5 times 8 is 40. I'm going to list my pairs that multiply to be 40. 1 times 40, 2 times 20, 3 does not go in, but 4 times 10 does, and also 5 times 8. which one of these pairs can add to be my middle term of 14? Well, I believe 4 and 10 here. 4 plus 10 is 14, and 4 times 10 is 40. Awesome. So I'd have to split the 14x into this pair, and you can put them in any order you want. Because the 5 comes first, I'm going to put the 10 next to it. I'm going to put 10x plus 4x, bring down the 5x squared. The 10 is positive. The 8 bring down is positive, equals 0. Now that I have 4 terms, I can group. So if I look at my GCF of the first two, I can take out a 5 and an x, and I'm left with x plus 2. Then the second two terms, I can bring down the plus and take out a 4, and also I'm left with x plus 2. So if I continue factoring this by grouping, I would have x plus 2 as one parenthesis, because this is my new GCF, and then I'm left with 5x plus 4. And remember, it's still equal to 0. So this seems like a problem that never ends, because I still need my answers for x. So now I would take x plus 2 and equal it to 0. And if I subtract 2, one of my answers would be x equals negative 2. And then if I set the other parenthesis, 5x plus 4 equal to 0, and subtract the 4 first, 5x equals negative 4. We would divide by 5 and get my other answer for x as negative 4/5. So for your test, please note that there is a big difference between something like number 17 and something like the first examples we did, numbers 1 to 10 or 1 to 11. That all of these are just expressions, so you're done when you're factoring here. You're not setting it equal to 0. The only time you go farther is if you notice it's an equation. So please, please keep note of that for your test. Numbers 18 and 19, these are from Chapter 7, the exponent rules that really apply to polynomials as well. So my goal is to simplify this. When I am taking a polynomial divided by another polynomial or a monomial divided by a monomial, I need to divide the numbers and subtract the exponents. So if I separate this, we'd have 4/12 in front. I can subtract my like exponents, so I'd have x to the 8 minus 4 power, and y to the negative 5 minus negative 1 power. If I simplify these things, let's leave the 4/12 for now, but this would become x to the 4th, and this would become y to the, this becomes a plus, negative 4th power. This, remember we're not subtracting these because these are not like bases, but we are simplifying. And I can divide both of these by 4, to make this 1/3 x to the 4th y to the negative 4th. Now if we want our answer to, again, leave answers as fractions, which I did, if you have a numerical base, please simplify, and you only want positive exponents. So what we have to do is flip this down to the bottom. So my final answer would be 1x to the 4th on the top and 3y to the 4th in the denominator. And no, you don't need that 1. So you could also write your answer as x to the 4th over 3y to the 4th. Number 19, also exponent rules. Let's get rid of these parentheses first. We want to raise both the negative 5 and the x to the 2nd power. And I'm going to copy everything else as I see it. Negative 5 squared is negative 5 times itself, so that's positive 25, x squared, y to the negative 8th, times 10, x to the 14th, y to the negative 7th. Unlike number 18 where I'm dividing, now I'm multiplying everything. So if we multiply straight across, we would multiply the numbers 25 times 10, and that would get me 250. I then would look at my like bases, and this is a circumstance where you add the exponents. X to the 2 plus 14 power, and then y to the negative 8th and y to the negative 7th will be y to the negative 8 plus negative 7 power. So my answer so far would be 250, x to the 16th, y to the negative 15th, but just like the previous example, this would have to flip. So my final answer will be 250, x to the 16th on the top, and the denominator will be y to the positive 15th. Final answer. All right, guys, in the next video, we will start with number 20 and finish up the review packet. Thank you.